You know, every building you see, every bridge you cross, every pipeline under your feet, it has an invisible twin, one made entirely of data. This digital architecture is what shapes our physical world, but for years it was written in two completely different languages. Today, we're going to dig into how bringing those two languages together, BIM and GIS, is sparking a revolution in how we build, well, everything.
Let's start with a number, a really big one, 125 billion. Just let that sink in for a second. By the year 2030, our planet will be home to an estimated 125 billion.
That's right, new connected devices. We are talking about a tidal wave of data. Pretty much everything is being metered, monitored, and mapped across the entire globe.
So, the big question is, how on earth do we manage all of that information? How do we actually harness it to build smarter, more sustainable places to live? Well, the answer lies with two key players in this whole digital revolution.
See, for decades, we've used these two incredibly powerful systems to design and understand our world. The catch? They were almost entirely separate. They are BIM and GIS. And you can really boil it down to the what versus the where.
This breakdown makes it super clear. On one side, you have BIM, that's Building Information Modeling. Think of it as the intensely detailed 3D blueprint of a specific thing, like a building. It knows about every single pipe in the walls. It tells you what something is. And on the other side, you have GIS, a Geographic Information System. That's the map. It puts that building into the real world, showing you how it relates to roads, power lines, maybe even a flood zone. It tells you where it is.
And to be a little more precise, BIM isn't just a 3D model you look at. It's a collaborative process. It's how all the different teams, architects, engineers, construction crews, all work together on one shared, information-packed digital prototype of an asset, from the first sketch all the way through to its final days.
And this really gets to a key idea here. You can't just go out and buy a box of BIM. It's not a single piece of software. It's a workflow, a whole way of working together that puts all the detailed information about a building or a bridge into one central place.
Okay, so if one system knows what you're building and the other knows where it is, you'd think they'd be best friends, right? Constantly chatting? Well, for a very long time, they weren't. They lived in completely separate digital worlds, creating what you could call the Great Information Divide.
The old way of doing things was, well, it was fractured. A project would start in the GIS world with planning and site selection. Then that information would get kind of thrown over the wall to the BIM world for all the detailed design and construction. And once it was finally built, it was thrown right back over to the GIS world for operations and maintenance.
This whole process created this false sense that you could just have a simple, clean handoff from one stage to the next. But that was a massive oversimplification. It led to lost data, incredibly expensive rework, and honestly, a total misunderstanding of how these complex projects actually work.
I love this quote because it's from a real customer, and it just perfectly captures the confusion. Everyone thought the solution had to be simple. Just create one new file format that both systems can read. But the problem was never the file. It was the entire broken workflow.
So the real breakthrough wasn't about a new file at all. It was about building a digital bridge. It was about a whole new way of thinking that connects these two worlds not just once, but in a continuous loop. Right. Instead of that clumsy, one-way handoff, the new model is a constant loop. Information flows back and forth nonstop, enriching both the detailed BIM model and the big-picture GIS map throughout the entire life of the project. And this new approach just shatters all those old barriers. Data suddenly flows efficiently instead of being trapped in different departments. And this is huge. Project owners get full continuous access to their own data, which drastically cuts down on uncertainty and, you guessed it, saves a whole lot of money.
So, how does this digital bridge actually work under the hood? Well, the big technical leap is that modern GIS software can now directly open and read a complex BIM file from a program like Revit. There's no messy conversion process anymore. It just understands the data as if it were born there. That's the magic that makes this whole loop possible.
So, that's the theory. But what happens when the blueprint and the map actually merge out there in the real world? Well, the results are pretty transformative.
Let me throw another number at you. $5.5 billion. That is a staggering amount of money, and that's how much was spent on construction projects at just one university campus over a 4-year period. Can you imagine trying to manage that level of complexity with disconnected blueprints and maps? It would be pure chaos. You need a single, unified view of everything.
The Nashville airport is a perfect real-world example. Before this integration, they had a folder stuffed with dozens of separate, complicated BIM models. No one could see the big picture. Afterwards, all of those models were combined into a single interactive 3D scene, placed perfectly in its real-world location, and get this, made accessible to anyone through a simple web browser. It was a moment where the team said it just magically worked.
The result of this process is what the industry is calling a digital twin. It's a living, breathing, digital replica of a physical place, an airport, a university, even a whole city, where every single component, every pipe, every wall, every runway is visible and understandable in its complete context.
So why does all of this matter to you? Well, because this integration saves massive amounts of money by reducing risk and guesswork in construction. It lets planners make smarter, more sustainable decisions about the infrastructure we all use every day. It's the absolute foundation for the smart cities of the future. It gives us a unified, intelligent view of our entire built world.
We are building a complete digital replica of our physical world, a true digital twin. The question is no longer if we can do it. The real question we have to ask ourselves now is, how are we going to use this incredible new power to build a smarter, safer, and more sustainable future for everyone?